recordings. So today, just I'll give you the control. Let's type down your. Sayed, please type your email ID on the screen. You have my keyboard control. You can just type down your email ID on this notepad. Okay. Now, Ali, I already have. Janardhanan, please type your email ID. Yeah, Janardhanan. It's not working. No, it should. Just check. I've given you the control. Yes, Ali, you can get your coffee. No problem. Anjum, can you please
Thank you.
post your Anjum, can you please post your email in the chat? Because you are on phone, I cannot give my control to you, so you can just post your email on chat again. I'll just copy and paste from there.
Okay, 1 second, sir. Actually, I'm driving right now. 1 second.
Yeah, you can give me later. Don't worry. Don't. You just drive and reach home safely. You can give me later on. Okay. During the session, you can give me later. No problem.
All right. Thank you, sir.
Yeah.
Sir, I sent it to you.
Yes, I got it. Okay, guys, so I'm taking this topology for our static routing. I'm going to start today, and this today's class will be completely dedicated to the static routing. We'll have different things on static routing that are possible. So what do I have in this topology is I have three devices, three routers, and this is my router number one, the first router. I'll just change the host name for this. Not taking the host name. Okay, so it's not taking the R1. So let us say we have this router number 4, router number 2, router number G. We have this R2, R3, and R4. What do I have is R2 is directly connected to 2.2.2.0, which is going to be the loopback interface on R2. And R2 will also have this fast Ethernet connection 0/0 to the network 10.1.23.0, which is a common network shared by R3 as well. So between R2 and R3, they will be connected on this subnet 10.1.23.0. R3 will have three different networks. One is the loopback 3.3.3.0, and two more networks are there. One is connected to directly with FA0/0 interface, and another one is directly connected on FA0/1 interface, which is 10.1.34.0. R4 will also have two routes. One is for the subnet 444 and one is for the subnet 10.1.34.0. Okay, so right now, let me quickly give the IP addresses to all the devices.
Hi, sir. I just joined. Did I miss anything?
Who's this? Anjum?
Yes, sir.
No, you didn't miss anything. I just made this topology and started giving the IP addresses.
The same from yesterday, right?
Yes. I'm just making the topology.
Okay, thanks.
Okay, guys, right now, you know from the IP routing basics that we have done till now, you should know that right now, if you look at the diagram here, this complete topology of these three routers has 5 different subnets. In this topology, in this diagram, I'm using 5 different subnets. So one is the 2.2.2.0/24, another one is 10.1.23.0/24, another one is 3.3.3.0, 10.1.34.0, and 4.4.4.0 are the 5 subnets right now in this diagram that I'm using between R2, R3, and R4. Right? 1, 2, 3, 4, and 5. 5 different networks I'm using right now in this topology. Now, guys, you should know that by default, when you do not do any type of routing, not static, not RIP, EIGRP, OSPF, BGP, means when you do not enable any routing, by default, a router knows only about its directly connected subnets. Right? We have seen that routers, each interface would be always connected to a new network, okay, a different network. You will never find out single routers two interface going to same subnet. Okay, remember this: routers, each interface will always be connected to a different subnet, because router is to provide routing between two different network. You will never find out that two of a router's interface going to the same network. So right now, in this topology, as I've just now shown you, that we have 5 different subnets between R2 and R3 and R4. So right now, when there's no routing happening between R2, R3, R4, R2 will know only 2 networks out of 5. Yes, Anjum, I'll just give you the recording access. Yes, Anjum, you can record now. So what I was talking is, right now, when R2, R3, R4 are not participating into any type of routing, R2 will know about 2 of those 5 networks, which are 2.0/24, and another one is going to be 10.1.23.0, which is connected directly via FA0/0 interface, right? Because R2 is directly connected to 222 and 10.1.23.0. R3 is directly connected to the loopback 0, which is 333, fast Ethernet 0/0, which is 10.1.23.0, fast Ethernet 0/1, which is 10.1.34.0, and R4 is directly connected via FA0/0 to 34.0 network and via loopback 0 to this 4.4.4.0 network. Okay, so here guys, if you check on R2, this is simply the same that we have discussed till now. As I told you that whenever you have an IP address assigned on a router's interface, that router is going to install a route for that interface for the connected subnet, right? Three information again: prefix, prefix length, and the next hop IP or exit interface. So that is taken from the way you assign an IP address on the interface. So here if you check show IP route, R2 knows about 2.2.2.0 and 10.1.23.0. And 2.2.2 network is connected via loopback 0, which is directly connected, and 10.1.23.0 is directly connected via fast ethernet 0/0. I'll go to R3 and do the same show IP route, because R3 I have put three different interface on R3 connected to three different subnets. So R3 will by default maintain three different routes, right? One for the 23, one for the 34, one for the loopback, which is 333. That's what you can see. And R4 will also have the same 34 and 444. Only the directly connected information they know about. They are never going to know by default that what is there in this topology which is not directly connected. Okay, so what we are going to do with this topology, we will make everyone to be reachable to everyone. Like right now, if I want to provide complete reachability between these three devices, I have to configure some type of routing on R2, R3, and R4 to tell them, to tell R2 about this network, and that network, right? Because for R2, this is what the R2 doesn't know about. R2 already knows about these two. If I tell these three information as well to R2, then R2 will be reachable to all five networks in this topology. Same goes for R3. R3 is directly connected to this, and this. If I define a route on R3 for 444 and 222, R3 would be reachable to all five networks in this topology. On R4, I have to define for 333, 10.1.23, and 2.2.2.0, because this is what is not directly connected to R4. Okay, so do you get my point here? The complete reachability, by default every device knows only about directly connected subnets, so they have to share information either manually or dynamically. Guys, anyone, if you have any questions, you can just stop me and talk to me. Okay, you can ask me doubts anytime during the session. So the thing is here, when you assign an IP address, based on that IP address we install three information: network, subnet mask, and exit interface or next hop. Okay, now when I was putting the directly connected subnet, okay, when you see this directly connected route in each router's routing table, I did not tell anything to R2. R2 just took this three information: network, subnet mask, and exit interface, from the way we assign IP address to the interface, right? This one. Now, guys, now there should be some type of routing for them to share information which they know about. R4 should tell about these two information to R3. R3 should tell about these three information to the rest. So if they start talking to each other and they start sharing whatever they are directly connected, then everyone will come to know about everything in this topology. But that is going to happen when you enable dynamic routing, either with RIP, OSPF, BGP, EIGRP, means some type of dynamic routing when you enable. But right now we are not doing dynamic routing, we will be doing static routing. So guys, to make a routing entry in my table, I need these three information: What if I tell these three information manually on router number 2, and manually I'll go to R3 and tell router number 3 and router number 4. Right, guys, looking at this diagram, just check on this diagram. On R2, if R2 wants to reach 333, if I want to define a route, if I want to tell, let's say R2 is some guy, and I know this in this topology that 333 exists on the right side of R2, right? For us, if you look at the diagram, this 333 exists on the right side of R2, right? If you look at from our end, 333 exists on the right side of R2. So why not I can go to R2, we can go to R2 and we can tell, hello R2, if you want to reach 3.3.3.0/24 network, go your right. Go your right. Go your right means what? Go to your FA0/0 interface. Right? If R2 wants to reach 333/0 .0/24 network, R2 can just take its FA0/0 interface and he can actually move into the direction to reach 333 network, and that would be the perfect way to reach 333. If R2 wants to reach 10.1.34.0, the best way, the best possible way for R2 is again FA0/0 interface. If R2 wants to reach 4.4.4.0, again the direction towards 444 is going to be FA0/0 interface, right? Because from the topology itself, guys, this is just like normally when you have some destination over here. Let's say you are standing here and you have few destination on your left and you have few destination on your right. So when you have A, B and C destination on your right, and you have D, E and F destination on your left, so to reach D, E, F you should always route through your left. For ABC you should always route through your right. So this is what we are just taking from the diagram. It happens just the same way for the routers. If R2 wants to communicate to these three networks, R2 should just forward packet to FA0/0 and that packet will reach to R3. And does R3 know about 333? Yes, R3 is directly connected, so R3 will be able to forward the packet and R3 can respond back to R2 in case the return traffic is also available. Right? So remember, whenever you make communication in a network, whenever two devices communicate in a network, it is always two-way. Okay, it's not never gonna be a one-way communication. So let's say from R2 I'm trying to reach R4. Okay, I made a ping from R2. I made a ping to 4.4.4.0, 4.4.4.4 using my source of 2.2.2.2. If I'm making a ping using my source of 2.2.2.2, when packet goes to R4, right? Packet goes to R4. Now, when packet will be sent back to R2, when the response will come from R4, the source of 2.2.2.2 becomes the destination for R4, right? Whatever the source was, when packet left R2, it was source, and 4.4.4.4 was the destination. When R3 forwards it, it was 2.2.2 was the source and 444 was the destination. When R4 receives it, the packet, again 2.2.2 was the source and 4.4 was the destination. But when R4 processes the packet and R4 is trying to respond to the source, which is 2.2.2.2, R4 changes the source as 4.4.4.4 now, and destination will be 2.2.2. Simple logic. When R2 goes to R4, R2 is the source, R4 is the destination. When R4 goes to R2, R4 is the source, R2 becomes the destination. So if R2 knows how to reach 444 and R4 doesn't know how to reach 2.2.2.2, communication is not going to happen. Okay, so communication is not going to happen because communication is always two-way. It's just same like when you plan a trip. When you plan a trip, let's say you plan a trip for Malaysia, and you are never going to plan the trip that I just need to go to Malaysia, I will never come back. You never do that, right? Whenever you plan a trip, you actually plan the trip both way, right? Going there and coming back. You're never going to just stay on those destinations. So here it's the same thing. When R2 is planning a trip from here to here, R2 should know that how to come back from here to back to R2. Okay, this is, you should remember. So if the ping is not happening, maybe if the communication is not happening from one point to another point, maybe the reason is that my end-to-end routing is not available. Okay, another thing here, when the packet, when I'm trying to make a communication from R2 2.2.2 to 4.4.4.4, you know that R3 is sitting between R2 and R4. Remember, R3 should know about 2.2 and 4.4.4 both. Okay, because because the packet from 2.2.2 is not going to jump and avoid R3 and reach to R4. The packet has to route via R3. It is just like some of your friend is sitting in between, and when you are sending a packet with a source address of 2.2.2.2 and the destination address of 4.4.4.4, the friend who's sitting between you and your another friend, if this middle friend doesn't know about 2.2 and 4.4.4, the R3, the middle friend, is going to drop the packet because he doesn't know about the end-to-end source and destination. So this is also another thing that you should remember. If I have between R2 and R4, hundreds of routers are sitting in between. All the hundreds of routers should have the end-to-end route for 2.2 and 4.4.4, or whatever the source and destination of the packets are. Guys, up to this point, any question, any doubt? Simple.
Yes, it's okay.
So here, now we are supposed to do here the static routing, right? We are supposed to do the static routing. Static routing is nothing but going to this guy, manually going to this guy and telling that, hello, whatever the name is, let's say his name is Z. Okay, his name is Z, his name is Z. So I went to this guy, I said, hello Z, if you want to reach A, B, and C, go your right. If you want to reach D, E, F, go your left. That's it. Static is done. Do you understand? If you tell a router these three things manually to define a route, that's what static routing is. Okay. So you can just make a note for static route. So when we manually define the network mask and exit interface or next hop IP parameters on a router in order to reach, in order to create a route into the routing table, you can also say to reach a destination. So when we manually define the network mask exit interface on next hop IP parameters on a router in order to create a route into the routing table to reach a destination network, that's what static routing is. Okay, so there's nothing that is going to happen automatically. They're not going to talk to each other. They're not going to share any information dynamically. You have to tell those parameters manually by going to the devices. Just note it down. Done. Now the syntax to configure IP, the static route. The command is going to be IP route. Then you need to, as I told you, that you need to specify what? Network. Then I will specify what? Mask. And then either exit interface or next hop. This is what the command syntax is going to be to define a static route on a router. Just note it down. So right now, if I take you to the topology again, so same thing we are going to define on R2. I'm going to tell on R2 that if you want to reach 333 network, take your FA0/0 interface, or next hop IP will be whom? Next hop IP is nothing but your directly connected remote device towards the direction of your destination. So if R2 wants to reach 333, who's the next hop device for R2? That's going to be R3, because R2 is directly connected to R3 in order to reach any of these destinations, right? So for R2, next hop IP will be 10.1.23.3, which is this interface IP address. Okay, what I'm going to do here now also, these interfaces, I'm going to change the MAC address of this interface as this. I'm just making it easy to identify the device here. So this will be 2, and that's it. I'm not going to change on R3 and R4. Just F is equal to 0. This is the MAC address. F is equal to 0. That's the MAC address. So if I go to R2 and say right now, if you check, do show interface F is equal to 0. Why I'm changing the MAC address? Because right now this has some MAC address which is not that easy to identify R2. Okay, so for learning purpose, I'm just changing the software based MAC address with the command MAC address. You can note it down. Okay, interface faster than 0/0. MAC address is this. This is not going to change the burned in MAC address. Remember, the MAC address which it has got from the manufacturer, that MAC address is still going to be same. What is it's going to change is the software based MAC address for our learning purpose. You can see address is this, the new address, but the BIA, which is burned in address, is still the same. So this is just the temporary changing the MAC address for our understanding, so that if I see 0001, I can easily identify that that's my R2. Basically, I should say here 2, and here I'm going to say 3. On R3, I'll just go to interface fast Ethernet 0 and say MAC address.
Sir, so in the MAC address table, which MAC address is going to show up?
That's the same one which you are assigning to the interface.
Oh, okay.
Okay. So on R2, R3, R4, we have put the IP address, and MAC address I've done on R2 and R3, just like the way we have put on the screen. So now on R2, I'm going to tell in order to reach, right now if you check to show IP route on R2, R2 knows about 10.1.23 network via fast Ethernet 0/0 and 2.2.2.0 network via loopback 0. If I try to ping from R2, do ping 10.1.23.3, which is R3 connected on this interface, I should be able to route the packet because I have a matching route in my routing table, right? First ping got dropped, then I was able to send all the ping packets to R3, which is 10.1.23.3. Now, in order to reach any other destination, let's say 333, because of not having any route for 333 network in the table, I should drop all the packets, right? If I try to ping 4.4.4.4, that is also going to be dropped, because remember, whenever a packet comes to router, you just need to check the routing table. Okay, whenever you troubleshoot, the first step should be, do you have a route to reach the destination network? If you do not, then you can never reach the destination. So you can see I only know about these two destinations, so I can only route the packet towards these two directions. So I'm going to put now a static route, IP route. The command is IP route. I'm manually going to R2 and telling R2, if you want to go to 3.3.3.0 network with a subnet mask of /24 255.255.255.0, take your exit interface of fast Ethernet 0/0. Just manually going to R2 and telling the direction towards reaching 3.3.3.0 network in this topology. Good. So first of all, we are going to see in static route can either be configured. You can see here I put both the option, exit interface or next hop IP. So static route can either be configured using exit interface or next hop IP. Correct? Now, both the exit interface and next hop IP, when you do configuration based on exit interface and next hop IP, both have their own pros and cons, means the own characteristics that we need to actually learn, that what happens when we define using exit interface and what happens when we use next hop IP. So first of all, as you can see on the command line, right now what option I've used the exit interface, right? I should have also defined next hop IP of 10.1.23.3 because that's my next hop. Next hop is nothing but my directly connected neighbor, you can say. So here I'm not using next hop, I'm using the exit interface option. So if you check now, show IP route, so I'm going to put here what happens first when you use static route using exit interface. When you put static route using exit interface, you can start making notes on this. So we are going to talk the details that actually happens when you configure a static route using exit interface. So right now, if you put show IP route, this router is going to have a S route because static route has the route code of S. You can see the second route on the screen is 3.3.3.0 and it says is directly connected via fast Ethernet 0/0. Okay, just like any other route, you can see 2.2.2.0, which was connected route, it's directly connected via loopback 0, and same thing you can see is displayed in this entry, which I have manually told to this R2 that 333 in order to reach the network 333, take your fast Ethernet 0/0 interface. So here, if I try to ping 3.3.3.3, okay, and before this, let me show you the up table of R2. Okay, right now you can see R2 knows about its own IP address. What is my MAC address? My own MAC address of this for this IP address. The MAC address is 0002, which I have just now assigned to the interface fast Ethernet 0/0, right? This F is 0/0 has an IP address of 10.1.23.2 and the MAC address for that interface is this. So that's what you can see here. 2 for interface fast Ethernet 0/0. Now on the same interface, I've also learned R3's MAC address because that's what is connected on that interface, and that says 23.3 is having this MAC address of 3, which was that's what I have assigned to R3F is 0/0. Okay, now you know that whenever we actually try to reach a destination, the packet should know about source IP address. We need 4 information. we need here 4 information to forward a packet into the Ethernet network. We need source, destination, source, and destination. Source IP, destination IP, source MAC, and destination MAC. Right now, when I will here from R2, if I will try to ping, let's say 3.3.3.3 guys, here I would know about the source IP, right? Because I can take the exit interface source, let's say 23.2, which is going to be this interface. So I know that I can take my source. By default, R2 takes, you don't need to specify the source. By default, if you have routing, whatever interface it is routing through, that interface will become the source of the packet. So here you can see that 10.1.23.2 will be the source IP address, and I'm trying to reach where? 3.3.3.3. That's going to be my destination IP address in this case, because I'm sending a ping communication to 333 network. Right? Now, do I know about source MAC? Yes, from the ARP table you can see I know that my source MAC is, you can see 10.1.23.2 is my source IP, so that has a hardware address, the MAC address of source as 002, which is gonna be this. Right? Now, what about destination MAC address here? Guys, I need destination MAC address, right, in order to forward the packet. You can see here, in order to reach from R2 to 3.3.3.3, I need the MAC address of 3.3.3.3 IP address, correct? So to get the MAC address of 3, in order to send ARP request to, in case let's say I am sending an ARP request to 3.3.3.3, that ARP request, you know that ARP is always what? A broadcast communication, right? ARP is a broadcast communication. ARP is a broadcast packet. So when R2, in case R2 sends an ARP request to 3.3.3.3, that ARP request will hit F0/0 interface of R3, and R3 will drop it, because router never forwards broadcast communication. In case a router receives on any of its interface a broadcast packet, means a packet which is going to a destination of 255.255.255.255, or on layer 2 FFFFFF, the router is just going to drop that communication. Okay, routers are not designed to forward broadcast packet in your network. Okay, otherwise if routers are not dropping broadcast, then every time, each time sitting, when here hundreds of devices are sitting on a LAN, and you know that every second, every minute, somewhere some device is doing the broadcast in my network. So if R2 will, let's say here on this LAN, R2 is forwarding all the broadcasts coming from LAN to the WAN, that doesn't make it feasible, because routers are typically connected to the internet, and if all the routers are forwarding their local broadcast which are happening into their local network to the internet, the whole complete internet will go down in a second. So that's the reason R2, R3, R4, or any other device, any other router basically is not going to forward the broadcast communication here. So when ARP packet hits R3, this interface, ARP packet will be dropped. That means my ARP request cannot reach to 3.3.3 network, because that is another subnet, another interface, another broadcast domain here basically, which cannot receive my broadcast packet, my ARP packet, if I'm doing ARP request for 333. So what happens here, guys, because I need destination MAC address, and I don't know that who is my, because here you should understand that when packet is going to leave from R2, packet should have a source MAC address of this 0002, and packet should have a destination MAC address of this, right? But because I have not told to R2 that what is going to be your next hop IP, R2 does not know that in order to reach 333 whom I should reach. Okay, let me take an example. Let's say there are 3 guys standing here. This is A, this is B, and that's my C. They are directly connected to each other. Now this guy is connected to some destination. Let's say he knows about 123, and this guy knows about 456. So this is, let's say, this is the left direction of this guy B, and this is the right direction of this guy B. So right now you can see B's neighbor on the left side is A, on the right side B's neighbor is C, in order to reach 1 2 3 and 4 5 6, right? If B wants to reach to 1 2 3, he should come to C, and if B want to reach to 4 5 6, he should come to A. But here when you define exit interface, it is like, it is similar to like telling this B, the guy B, that in order to reach 1 2 3, take your left. In order to reach 4 5 6, take your right, and in order to reach 4 5 6, take your left. I have not told to B that your neighbor, in order to reach 4 5 6, you should go to A. In order to reach 1 2 3, you should go to C. Right? Guys, did you understand this or not? R3, I did not tell that in order to reach, on R2, I did not tell that in order to reach 333, you should go to R3, means 10.1.23.3. I just told to R2 that take your F0/0 interface in order to reach 333. So R2 didn't know that whom I should reach on this segment, who should be my local neighbor that I should get the MAC address of, right? So here you need to understand what happens in defining exit interface, that ARP request will be sent for the destination IP address, and now if I'm sending ARP request, guys, in this topology from R2 to reach 333, in case I send ARP request for 333, 333 can never receive my ARP request. So what happens when I'm sending ARP request for the destination IP address? The next hop router does the proxy ARP and gives its own MAC address on behalf of the destination IP address. Do you understand? Proxy attendance, you might have heard. So when you are responding on behalf of someone else, that's called proxy ARP. What is going to happen in this topology, guys, when R2 knows here, R2, we know that R2 cannot reach to 333, right? R2's ARP request, basically. R2's ARP request sent by R2 cannot reach 333, but R2 will still send, because R2 doesn't know who is R3. I do not specify about the next hop IP device, so I did not tell R2 that who's your next hop, which is 10.1.23.3. So what R2 is going to do, R2 is going to send ARP request to 333, but that ARP request, when R3 receives, R3 is going to drop the ARP request, but R3 is going to do a good job for R2. What it is going to do, on behalf of 3.3.3.3, R3 is going to give its own MAC address of this interface to R2. Okay, what R3 is going to tell, okay, R2, you want to reach to 333, take my MAC address and come to me, I will take you there.
So sir, it has to look into its own routing table and check if it has routes for 333, right?
Yes, true. That is true, because otherwise it's not gonna be able to forward the packet. So guys, did you understand this? Everyone, did you understand up to this point, guys? Are you with me, everyone?
Yes.
So sir, does it do for every broadcast that it receives? It will check routing table, see if it can reply with its own MAC address.
Yes, it is going to reply, but remember, for different destination, okay? Not for the same destination again and again. For different destination, it's going to do the same.
So I didn't understand. So different destination.
Different destination means here, if R2 is trying to reach 333, Then first time it will send ARP request for 333, R3 checks it, and R3 replies with its own MAC address and replies it to R2. Okay, gives the MAC address to R2. Now when again R2 is sending packet to R3, now
Oh, it already has it now.
yeah, it already has it now. That's what I'm
But
telling.
but is it going to look into the routing table and see all the connected networks and only then reply, or is it going to see in the routing table and
No,
reply for all
no,
networks
no.
that are
See, when R2 sends a broadcast for any IP address, when R2 sends a broadcast, R3 would reply with its own MAC address. Means any ARP request that R3 receives from R2, R3 will respond to that with its own MAC address. You just need to understand that.
Oh, okay. And then even if it cannot reach that network, it will still reply with the MAC address and then drop that packet when it comes?
Yes, true.
Okay.
Only R2 is going to check in order to forward the ARP request. ARP request will be forwarded only when R2 knows about the destination.
Right. But if for example, if R2 is trying to send a packet to 555
Then it's
and
gonna just
R3,
drop.
but it will reply with its MAC address.
Yeah, true.
Okay.
So here, let's go to R2 now, and to show this, I'll show you with the help of debug. So when you do debug ARP, and when you try to ping 3.3.3.3, guys, can I reach 3.3.3.3 network right now? I have just defined one static route on R2. I didn't do any routing on R3. Can I reach from R2 to 3.3.3 loop back? Okay, Janardhan says yes. Yes, Anjum? Syed Ali? What about you guys? Can I reach there?
Sir, from where to where?
From R2, this ping. From R2 to R3's loop back.
Can you
Yes.
see R3 routing table?
R3 routing table is this.
R2. Yes.
Yes or no?
Yes.
Yes.
Yes, we should be able to ping, because right now by default R2 is going to take the source IP address of the packet of interface F is plus 0, right, which is going to be 10.1.23.2. R3 is directly connected to the subnet, right? So R3 can route packet back to 10.1.23. But if I ping using my source of 2.2.2.2, because R3 doesn't know how to reply back to 2.2.2.2, that ping is not going to work. So check what is going to happen. First of all, the proxy ARP is going to happen. So what happens, the first entry was incomplete, creating an incomplete IP entry because I didn't know the MAC address of this. Now I'm sending a ARP request, sent request from source of 10.1.23.2, which is my own MAC IP address, using my own MAC address, and sending to destination of 333, and MAC address is 00 because I don't know who's 333. Then in received, when I received the reply from the source of 333, I got MAC address of whom, guys? You can see this 00003 is the MAC address of interface fast Ethernet 0 of R3. Right? This is not the MAC address that belong to 3.3.3.3, but R3 is replying on behalf of 333 with its own MAC address of this. So if you check on show ARP, I got the success, right? The ping was success. If you check show ARP, it makes an entry that in order to reach 3.3.3.3, I'm going to take my hardware address of 00003, which is R3 FA0/0 interface, right? In order to reach, let's say, if I try to ping 3.3.3.4, guys, what is going to happen here? 3.3.3.3 is an IP address assigned on R3. What if I ping 3.3.3.4? Can I route this packet? R2, can R2 route this packet, guys?
No.
Yes, why not?
Oh, I mean, but there is no device, so it will route it, but it will
Yeah,
say
true.
not there.
That's what my question was. Can the device route the packet? I didn't ask that whether it can get the reply or not. It will not get reply because there is no device called 3.3.3.4, right? But R2 will be able to route the packet because I have a matching route to that destination of 3.3.3.4, because I have a 3.3.3.0/24. Remember, because I have 3.3.3.0/24, I'm going to match only 3 octet, right? /24 means what? When I'm trying to ping 3.3.3.4, I'm only going to match the first 3 octet to this routing entry, and which are matching right now. I don't care what comes in the fourth octet. So this will be forwarded if you check debug IP packet detail. And before that, what I was trying to show you is, if you check 3.3.3.4, right, the packet cannot reach to this destination, but still what is happening, R2 again send the ARP request from same source, and what it got is the same thing from R3. I got 0% success because there was no device who's going to respond. But you can see what I'm getting here is R3's MAC address in order to the response. If you check show ARP for 3.3.3.4 also, I have an entry of this. So R3 is not going to check the connectivity and try to ping before replying for the ARP request. It is just going to reply. Any broadcast comes, I'm going to reply. If you try to ping, let's say 1.2.3.4 here, now the nothing happened here, right? If you check here on show ARP for 1.2.3.3, I didn't do anything because 1.2.3.4 was not available in my routing table. So before I'm going to send the ARP request, I'm going to check on R2. I'm going to check whether I have the route in the table or not, because only when you have a route, then only you will try to forward the packet towards the destination. Yes, any question, guys? Okay, so here on R2, now R2 is able to reach to this destination. Let me stop the debug first. So show IP route. Write down few points when you define exit interface with your static route. What happens is, you can see, guys, this is installed as directly connected. Okay, there are few differences when you install the static route using exit interface and next hop IP. Right now, when you define exit interface in order to reach the destination in the static route, it is installed as directly connected. So another point we can write down, the route, this is under this. Okay, remember, don't forget to put this. The points which are talking right now are under static route using exit interface we are talking. So the route is shown as directly connected in the routing table. Now, guys, what is the AD value for static route using exit interface?
0.
Okay, 0. Who's this?
No, I think it was 1. The zeros were connected.
Okay, yeah, Janardhanan, Ali, Sayed, what is the static route AD value? Yes, guys, give me the response. Janardhan, what's your call on this? What's the AD value for static route using exit interface? Ali, Sayed? Guys, everyone with me or not? Sayed and Ali, guys, where are you? Yes, Sayed, what's the AD value for this static route using exit interface?
1.
Okay, so Anjum says 0. Janardhan says 0, and Sayed said 1, right?
No, Ali.
Ali said 1, and Sayed said what? Sayed? 0. And what if I configure static route using next hop IP then? Okay, guys, you guys are having this wrong concept here, because remember, AD value of a static route is always 1. No matter this is using exit interface or next hop IP. Okay, AD value of a static route is always 1, because 0 is for directly connected, right? Static route, even if you define using exit interface, that is shown as directly connected, but that is not actually directly connected to the router. If you go to R2, this is shown as directly connected, but is it directly connected to R2? No, this 3.3.3.0 is directly connected to R3. So let me show this to you. Remember, make a note of this. Write down, static route always has an AD value of 1. Okay, make a note on this. Static route always has an AD value of 1. So I'm going to put 1 here, which is same even if you define next hop IP address in your static route. Okay, guys, we'll stop for 5 minutes and then we'll be coming back to continue. Okay, everyone? Okay, let's start, guys. Everyone is here? So here, remember, AD value is always 1. To show you this in detail, I'll go to R2, and when I put this static route, remember I've shown you this debug called debug IP routing, which shows you all the changes that are happening with your routing table. So if I enable this debug, and right now there will be no route, right? There's no static route now because I have put no to that command, right? No IP route. I've removed that static route. Now after enabling the debug, if you again put this static route command, this will show you that the AD value is 1. Even if you put exit interface, the AD value is 1. This information is not shown in the routing table. This information is not shown in the routing table. If you configure static route using exit interface, if you check do show IP route, this is not there in the routing table, but the debug shows you that static metric, this is the AD value and this is the metric. Metric will always be a 0 here. Static doesn't have a metric. Metric is always 0. But the AD value, even if you define exit interface or the next hop IP, it's always going to be 1. Clear, guys? So now show ARP. What do I have in ARP table? I have two different entries. If I try to ping 3.3.3.3, enter, I'll be sending an ARP request and getting the proxy ARP. So you can write down proxy ARP we have already written. Now, second thing, the drawback of this is in case I ping 3.3.3.4, again the ARP request is sent, right? If I send 5, again the ARP request is done for 5. If I do 6, again the ARP request will be sent. So if I try to ping different destination, let's say hundreds of destination on that subnet 3.3.1, 2, 3, 4, 5, 6 like that, router number 2 is going to send ARP request every time, and that will make the ARP table of R2 a huge ARP table. You can see all those, and this will keep on increasing the size of the ARP table, the number of destination you ping. So you can write down ARP request is sent for each different destination, and that makes the ARP table huge. Excuse me. Okay, so the number of destination you ping, number of destination you are going to, the ARP request you're going to do, and that's going to build your ARP table huge. Now, after this point, right now, if you check here, if R2 wants to route a packet to 3.3.3.0, okay, let me take you to the routing table of R2. We have this routing table, and that says that there is a static route 3.3.3.0/24 is directly connected via fast Ethernet 0/0 interface, right? If you try to ping 3.3.3.3, guys, you can see that this IP address will be forwarded using this static entry, right? And you can see this static entry 3.3.3.0 is directly connected via fast Ethernet 0/0. Remember, your IP routing is three-way process. The first day we discussed routing, switching, and encapsulation, correct? Routing, switching, and encapsulation. So in routing, if you remember, guys, if you take a review on your routing, routing is to do what? To find the exit interface, right? and exit interface for what? To forward the packet into the correct destination direction. Right, guys? Remember, routing is to do the route lookup process to find out the correct exit interface towards the destination. So now when R2 tries to ping 3.3.3.3, R2 checks its routing table, and from that routing table it sees, okay, this destination is reachable via fast Ethernet 0/0, means the same entry, same static route entry is providing me the exit interface information. Remember, this is very important. No matter by which routing table, which routing protocol you run to advertise the routing table, advertise the routing information, router will always have to know about the exit interface in order to forward the packet. Okay, so if let's say 3.3.3.3 is learned via 10.1.23.2, or 10.1.23 is learned via 10.1.12.1, or 10.1.12.1 is learned via someone else, a router will keep on doing the route lookup process until the router finds out the exit interface, right? Because router has to know that on which interface I need to forward this packet, on which interface, what should be my exit interface, what should be my outgoing interface in order to send this packet towards the direction to the destination. Okay, so here in exit interface, when you define static route using exit interface, your exit interface information is available on the static entry itself, but that will not be same in next hop IP. Okay, so do you get my point, guys? This static route itself is telling me the exit interface information. So you can see recursive route lookup is not required because the same static route tells about the exit interface information. Guys, if you want to know about recursive route lookup is nothing but when you do route lookup multiple times. Okay, you can write down another note, separate note, not in this exit interface. Recursive route lookup is nothing but when a router do, write down, when a router does route lookup process multiple time or more than once in order to find out the exit interface. When a router does multiple route lookup process in order to find out exit interface, that is called your recursive route lookup. Okay, recursive route lookup means you are not able to find out exit interface in the same route, the first route that you find out in the table. So you're doing route lookup multiple times. When you have to do route lookup process multiple times in order to find out the right exit interface, that is called recursive route lookup process. Okay, let me ask you one more thing, guys. Everyone is making proper notes or not? Or you guys are just listening it as a video? This is not a video training. Okay, this is not something that is already recorded or you are just sitting and doing the video listening. Okay, don't take it as that. This is a classroom, so make it interactive and make proper notes. Okay, whatever we do in the classroom, you all should make very good notes because that's is going to be very helpful uh, for your further studies. Okay, because when you are sitting in the classroom, it's easy because when I'm doing everything on the screen, you say, okay, I got it, but you cannot remember everything after you are done with the class. Okay, when the time passes, you actually start forgetting the things that you have done in the classroom. No matter how good you do that, but still you will miss few of the things. So if you make notes of everything, then you don't need to read any book, you don't need to listen to the videos again. You can just refer to your notes and you get the same idea about each topic. that you actually had in the classroom. So guys, Janardhanan, Ali, Sayyid, Anjum, all of you, all four of you, are you guys making notes of these things or not? Okay, Janardhanan is taking notes. Ali, Sayyid. Okay, what about Sayyid? Okay. Okay, that's good. So make proper notes. And I've got your mail IDs. I'll share the books, the PDF version of the new book, because right now the exam is changed, as I've told you that route version 2 and switch version 2 and t-shirt version 2 has come. So I'll share the new book for those.
So do you know how much of it has changed from the old book? Because I have hard copies of the old book.
Yeah, see, it's not a big change. If you just go to who is it, Anjum?
Yes, sir.
Yeah, Anjum, you missed the first class. Did you go through the first video?
Not yet.
That's why you should go, because I have discussed those things into the first videos.
Okay, all right. I'll go through it.
Yeah, so
Yep.
go through it. If you have any question, just let me know tomorrow.
Sure,
Okay?
sure, no problem.
So here I'll come back to this. So these are the points if you define static route using exit interface. Now one more point is left, which I will tell you after discussing about next hop IPs. So now here R2 is reachable to 3.3. Now let's do some reachability between R2, R3 and R4. Then we will move to next hop IP. So right now R2 can ping 3.3.3.3 because I have a route in the table, but R2 cannot still ping 3.10.1.23. That's my direct link. R2 cannot still ping 34.4, which is this link. Okay, 23.3 is directly connected, so I'm able to ping, but R2 can still not ping 10.1.34.4 because R2 has no idea about it. So if I want to do that, I can just go to the global configuration mode again. I can say 10.1.34.0 slash 24 is via 10.1. Or not the next up IP. I have to do the exit interface itself right now. Okay, another route is added to the table. You can see the debug says that 10.1.34.0 slash 24 via 0000 because I have specified the interface. So whenever you specify interface to the route, the next up IP is going to be 0. So we will have another static route in the table. You can see 10.1.34.0 is directly connected via fast Ethernet 0/0. Now, if I try to reach there, do ping 10.1.34.3. Guys, everyone, can I ping this address? Okay, Janardhan says yes. Ali says no. Anjum? Anjum and Syed. Okay, Anjum says yes. And Syed? Yes. If you hit enter, this R2 is able to ping the destination address of 10.1.34.3. You can see here I got the successful ping. The reason is because when R2 is sending packet, okay, who said no in the chat? Okay, Ali said no. Ali, you might have thought that R4 doesn't know, the 10.1.34 network doesn't know about how to reach R2. But remember, the destination I was trying to ping was 10.1.34.3, and that is an IP address assigned to R3's interface. Does R3 know how to reply back to 10.1.23.0? Yes, it is directly connected. But if you make a ping to 10.1.34.4, okay, this is an IP address on R4. If you hit enter, this ping is not going to work. You can see I'm getting dot dot dot. Why? Because this packet is going to R4, and does R4 know how to reach back to 10.1.23.0? Okay, let me show this with the debug. So if you say do debug IP packet detail, debugs are really good to use because those gives you very good detail about what you're doing on the screen now. So here, if you check 10.1.34.4, and if I go to R4 also and enable the same debug for the packet to see what is happening with the IP packets, if I hit enter, it is saying that I have routed the packet via fib. Okay, so R2 was able to do the routing, right? R2 was able to do the routing, but still there was no success, because when R4 is trying to reply from source of 10.1.34.4 back to 10.1.23.2, the packet is unroutable. I told you, by default source of the packet, if you do not specify any source with your ping communication, with your ping packet, if you do not specify any source IP address, the source IP address will be taken as the exit interface. And that's what you can see on R2. The source IP interface, the source IP was taken of the 10.1.23.2, because that's what the IP address is of this exit interface, right? I forwarded the packet out of f is 0/0 because I configured 10.1.34.0 network via f is 0/0. Okay, so this ping is not going to happen because R4 doesn't know how to reach back to 10.1.23.0, right? Correct. If I go to R4 and say IP route 10.1.23.0/24 is reachable via f is 0/0, because you can see R4, for R4 to reach 10.1.23.0 network, my correct exit interface is going to be f is 0/0. So if you go to R2 and try to ping now, this is going to work. You can see I'm going to get all the replies here, right? I've got, if you check by disabling this debug, if you make the ping again, I'm getting all the packet as success, because R4 is now able to route the packet back to R2. You can see previously this packet when I was replying from my source of 10.1.34.4 to destination of 10.1.23.2, which was the response for the ping communication coming from R2, I was not able to route. Previously it was coming as unroutable. Now I can route the packet via fib. Okay, so remember, I told you the very first thing. I told you that in case you are traveling to somewhere, you should know how to come back to your home. Okay, so when R2 sends communication, R4 should know how to reach back to R2. Now if I go to R2 right now, and right now I'm able to ping R3's loopback, which is just directly connected to R3, and that's loopback. I'm able to ping. But if I try to ping 3.3.3.3 using my source, I specify the source. By default, source will be this interface 10.1.23.2. But let's say I don't want to use that as my source. I want to use 1.1.1 as my source of the packet, ping packet. So can this ping work? This ping is not going to work, because for this ping to work, R3 should know that how to reach back to, sorry, this is the wrong IP I'm doing. It should be 2.2.2.2. So this, for this ping to work, R3 should know how to reply back to 2.2.2.2, which I think we have not specified anything on R3. So you can see there's no route for 2.2.2.2 in the table of R3. So when R2 tries to ping 3.3.3.3 using 2.2.2.2, R3 is not sending reply and R2 is getting ping drops, because if you do debug IP packet detail here as well, this will tell you that when R2 is trying to ping to that destination, R3 is not able to route the packet back to 2.2.2.2. Right, you can see the packet return traffic from 333 to 222 is unroutable. Good. So if I go to R3, I'll say IP route 2.2.2.0 255.255.255.0 is via f is 0/0, right? R3 to reach 2.2.2 is via f is 0/0. So when you do that, if you try to ping R2 from R2 to R3, this ping should work now, right? It's working fine because R3 is able to route the packet back to R2. Now, if I go to R2 and try to ping 4.4.4.4, this ping is not going to work because there's no route for 4.4.4 into the table of R2. You can see there's no route for R4's loopback. So if you say debug IP packet detail again, and then if you try to ping 4.4.4.4, this says that packet is unroutable. right? So I'll go to global configuration mode, say 4.4.4.0/24 and via f is 0/0. Same interface, because any destination into this direction will be reachable via fast Ethernet 0/0. Then if I try to ping now, this ping, is it going to work here? If I ping 4.4.4.4, enter, this ping is not working, and the reason is what? The reason is layer 2 fail. Layer 2 rewrite is failed, means the encapsulation process is failed. If you check show ARP 4.4.4.4, my entry is what? Incomplete. Okay, my entry is what? Incomplete, because here, as I told you, the very first thing, the communication to happen, if I take a new page here, the communication to happen, if I have devices like this, if R1 is trying to ping this R6, some network on R6, all these 4 devices in between should know about, let's say this is my 1.1.1.1, and here I have 6.6.6.6. All these middle 4 devices should know about 111 and 6.6.6.6, right? So if I go to R3 and check my table show IP route, R3 doesn't know about the 4.4.4.4, right? So I have to define a static route here for 4.4.4.4. IP route 4.4.4.0/24, and that's going to be via FA0/1 interface here. Correct? Now on R2, if I again make the ping 4.4.4.4, I'm getting success here. You can see the ping is getting success. If I stop the debug and then show you, I'm getting all the packet as success. Now if I try to ping 4.4.4.4 using the source address of 1.1.1.1, not 1.1, it's 2.2.2.2, and this is not going to work, because again the problem is R3 and R4 doesn't know how to reply back to 2.2.2.2, right? This ping is not happening. I got 0% because if you check on R3, R3 I think knows about 2.2.2 because we have specified, right? But the problem must be on R4, I guess, because R4 doesn't know how to reach back to 2.2.2.2. So if you do 2.2.2.0/24 via 0/0, this ping should work fine. Okay, because everyone knows about the source and destination now. Okay, so now everything is reachable from R2, R3, and R4. If you go to R4, you can ping 3.3.3.3. I think I did not specify this. Do show IP route. Yes, so I'll configure one for this one as well. Then everything will be reachable from anyone. So do ping 3.3.3.3. Success. Do ping 2.2.2.2. Do ping 10.1.23.2. Everything is reachable here. From here as well. Now show run section IP route. I'm going to copy all of its static route that are configured on this R2, and I'm going to put the same command on R3 and R4. Why I'm putting this? To get my commands, the IP route configuration, I'll take them on a notepad, and I'm going to put no in front of those commands. I'm going to remove them. So on R2, I'll just put no to everything, and on R3 also, I can just take it here and say no IP route this, and no IP route this. Done. On R4. Good. Now no one knows about anything. Show IP route. Good. Now, if you go to R2 and define a static route to reach 3.3.3.0/24, and this time I'm going to use the next up IP. Next up IP will be 10.1.23.3, because next up IP is nothing but the directly connected device, the remote device which is directly connected to me in direction of the destination network. Enter. So if I try to ping 3.3.3.3, and before this, if I show you the route, show IP route, this will be displayed in a different way. So you can see 3.3.3.0. Previously, these things were not mentioned there. It was shown as directly connected. Now it is telling you with AD value and metric in the table. And here it is via 10.1.23.3. Previously, it was shown as via some interface. Now this is shown as this. So let's write down these points when we are going to use.
Pawan,
Yes.
which is the best way whether to have interface or IP address?
Yeah, that I will talk when to configure with exit interface, when to configure IP address.
Okay.
So all of these things I'll just copy and edit them. Here our request will be sent for the next hop IP address, and AD value is 1 even for this next hop IP. ARP request is sent for, yeah, ARP request is not sent for each different destination. And so in ARP table, router will have only one single entry for the next hop IP address. Recursive route lookup process, recursive route lookup is required here because the same static route does not give the exit interface information. Okay, so here ARP request is not sent every time you ping different destination. ARP request is sent only for the next hop IP address, and because the ARP request is sent to the next hop IP address, there will be no proxy ARP because I'm not going to send ARP request for the destination IP address. and the route is not shown as directly connected, just like you have seen in the table. Route is shown via some IP address with the metric value and AD parameters. AD value is 1. ARP request is not, this is we have discussed. Recursive route lookup process is required because right now you can see, guys, if R2 is trying to reach 3.3.3.0, this is going to take via this entry, right? But this entry, does it tell me about my exit interface information? No, right? This doesn't give me the exit interface towards 333. So what we have to do, the router first have to check this entry. So 333 in this entry is reachable via 10.1.23.3. Then R2 has to again do a route lookup process to find out that 10.1.23.0 is directly connected via FA0/0. So until you find out this information, you will keep on doing route lookup process. Okay, it is same like when if for this guy, if this guy is reachable via this guy, let's say A, B, and C. If C is reachable via B, A should first know how to reach B. Then only he can reach to C. Right? In case A is not reachable to B, A should not get through to C. Right? So that's what here we have. That's what the last point is about. We have to do multiple time lookup. So let me show this to you. Right now, if you check show ARP, we have only a single entry for the next hop IP, which is 10.1.23.3. Let me remove this entry. I'll just shut down the interface and re-enable it. So the entry will be removed. Now if you check show ARP, there will be no entry for .3, right? There's no entry for .3. So if you do debug ARP and if you try to ping 3.3.3.3, enter. Here the ARP request is sent for 10.1.23.3 and 10.1.23 has this MAC address. That's what I'm getting here. Show ARP. You can see I got this MAC address. Now if I try to ping 3.3.3.4, previously what was happening, every time ARP request was sent, right? Right now no ARP request. If you check do show ARP, and there will be no entry like before. There will be just one entry for the next hop IP, because I know in order to reach any different destination, I need to put the MAC address, destination MAC address of my next hop IP, which is 10.1.23.3. Here I know who is my neighbor towards the destination of any destination. So if I configure an IP route for 10.1.23.0/24 via 10.1.23.3, I configure a route for 4.4.4.0/24 via 10.1.23.3, and if I go to R3, IP route 2.2.2.0 via 10.1.23.2 it will be, because for R3.2 will be the next hop IP to reach 2.2.2.2, and to reach 4.4.4.0, if I do 4.4.4.4, then this will be installed as what? /32. So it is just depending on the way you put the static route. So when I put 32, this will be installed as /32. Then on R4, I'll go to IP route 2.2.2.0/24 is reachable via 10.1.34.3. IP route 10.1.23.0/24 is reachable via 34.3 again. And also the loopback of R3 is reachable via 34.3. So from R2, if you ping any destination, let's say 10.1.23.3.4, it's not 23.4, it's 34.4. So 34.3. There's no static route for that. So ping 10.1.34.3, I should be able to ping. Yes, if I ping .4, I should be able to ping. If I ping 3.3.3.3, I was able to ping that, and 4.4.4 also. And all of them I can also ping using my source, so that I can specify that R4, R3 are also reachable back to me. Good. So this is it for today, guys. We will continue from here tomorrow. There are few more things that we'll be doing with static, like permanent static route, then we will do floating static route, and then I'll also do the tracking of a static route using the tracking object and SLF features. Okay, so in today's thing, guys, whatever we have covered in today's class, did you get everything? If you have any question about today's class, you can tell me, guys. So are you guys clear with all the things? Everyone? Anjum, Sayed, Ali, Janardhan?
Sir, I just had one question. So when we say next hop IP, it has to be directly connected to us, right?
Yes, it has to be directly connected, but we will do tomorrow. I'll show you that remote next hop IP also you can do here. Let's say from R2 right now, in order to reach from R2 to 4.4.4.0, my next hop IP should be 10.1.23.3. Means anything that is reachable in this direction, my next hop IP should be 10.1.23.3. But technically, if I go to R2 and put to reach 4.4.4.0, if I put my next hop IP as 10.1.34.4, do you understand? 10.1.34.4 is not directly connected to R2. I can put that, but then I have to put another static route to reach 10.1.34.0 via 10.1.23.0. So in that case, we will do it tomorrow, remote next hop IP. There's no benefit of doing it, but just for the sake of technical thing here, that technically you can do it, just for the knowledge sake, you can actually do that as well in your topology. So what you can do is you can define that to reach 4.4.4.4, my next hop IP is 10.1.34.4, and in order to reach 10.1.34, my next hop IP is 10.1.23.3, and in order to reach 10.1.23.3, I will use my F0/0 interface. So it is like 3-time lookup process we have to do, recursive lookup process, to reach this via this, to reach this via this, and to reach this via F0/0. Right? Who asked this question? Janardhan? Who was
that
it?
was me. Anjum.
Oh, yeah, Anjum. Okay, so we will do it tomorrow, guys. Any other thing that you want to talk to me, guys? Any other question? Did you understand everything? Okay. Yes, Sayed?
Yes.
Ali? What about Ali? Yes, Ali brother, where are you? You felt sleepy. Why? Is it boring? Ali, why did you feel asleep? Why?
Accidentally, actually, it's not boring because last night I sleep at 12 a.m. and then wake up at 3. So couldn't sleep well.
Yeah, don't sleep, bro. This is really important because this is what is the basic of all the dynamic routing protocols. If you learn this, the packet forwarding with static, then it's going to be same for all the dynamic. The only difference is the way they are going to behave is going to be different. So don't worry, you have the recording, Ali. You
Yeah,
can
I'll
go through the recording again. And
I'll review the recordings.
yes. Okay.
If I have any doubt, I'll send you email also.
Yes, sure, no problem. So guys, just keep on doing this. This is a simple lab. You can make the same lab in GNS3. Okay. And yes, I'll share the files today, and tomorrow, just remind me in the classroom. I'll show you how to do it. Okay. In the classroom itself, I'll show you how to do it. I'll share the files today on Google Drive file to everyone. You can just download that file, and tomorrow we will do it in the classroom. Okay, just remind me of that. Okay, everyone. So, bye bye. Take care.
Okay, thank you.
Time.
Thank you, sir.
Okay. Thank you.
Thank you.
Thank you.